Hello guys, this is Miss Hanley here, spending my snow day making videos for you. We're going to continue Unit 6 Part 3, and we're solving quadratic equations by completing the square. So today you're not actually going to be completing the square, but we're going to learn how to begin that. So this goes with assignment 13. So in order to complete the square, what we're really talking about when we say complete the square is a perfect square trinomial. So when I'm looking at this particular function here, x squared plus 6x plus 9, x squared plus 6x plus 9, this one happens to be a perfect square trinomial, and we want to think about why. Well, if I go ahead and factor this, I'm trying to think what multiplies to 9, what two numbers multiply to 9 that add to positive 6. Well, that would be 3 and 3. So this factors into x plus 3 times x plus 3, which is the same thing as x plus 3 squared. And the reason it's a perfect square trinomial is because it's one factor, x plus 3, that's been squared that gives us the result up here. So in order to complete the square, what we have to do is actually create these perfect square trinomials. And remember, to summarize, a perfect square trinomial, it's one factor that's being squared, and to recognize it, it's the first term squared, so a squared, whatever that is. The last term squared, b squared, goes in the end, and the middle is 2, so your exponent, times the first term times the second term. So if we were trying to simplify x plus 7 squared, we would get a squared, which in our case is the x. We would end with b squared, which would be 7 squared, or 49. And then the middle has to be 2 times 7 times x, which would be 14x. And so that there is your perfect square trinomial. That's what we're trying to create. Something that has the same number that you can multiply to get a product and add together to get a sum. Oops. Alright, so what we're going to be challenged with today is creating a perfect square trinomial if we're only given the first two parts of our polynomial. So here we're given x squared and a negative 10x. If you remember from your quadratic function, ax squared plus bx plus c, what we're given is the ax squared and the bx, but what we need to find, what's missing, is c. So I need to think about this in terms of finding a number that's going to be the same, and when I add that number to itself, I get negative 10. When I multiply those two numbers together, that's what's going to create c. So if I think about what two numbers add to negative 10, well, the two numbers that would be the same are going to be negative 5 and negative 5. To find c, you're going to be multiplying those two numbers. And negative 5 times negative 5 is going to be 25. So to complete our perfect square here, we have x squared minus 10x plus 25. If we were to then factor this, it would become x minus 5 squared, because 5 times 5 is 25, and negative 5 and negative 5 is negative 10. Okay, so for this part here, I'm going to demonstrate why we call this completing the square with a little bit of a more visual idea. So right now our equation is x squared plus 6x plus 9, and we call that a perfect square trinomial because it actually forms a perfect square if you think about it in terms of length, width, and area. So let's look at all the components here. I'm going to say that this blue box right here, the length of each side of this is x, alright? On the right hand side over here are these pink bars. The length of each one of these is x and the width is 1. And then each one of these little boxes is 1 by 1. Alright. Well, x times x is going to give you x squared. right? Which is the first piece to our polynomial. And then we have 6 x's. Well, 1 times x is just going to give me x. So I'm going to add on to this square that we've created, the x squared, 6 different pieces that are size, the area is size x. And so we have 1, 2, 3, oh no, sorry, not sure why I can't click on this. There we go, we'll move that back later. 4, 5, 6, and then each one of these smaller pieces is 1. And so I'm going to move these over one by one. And since it was x squared plus 6x plus 9, we want to have 9 of these little pieces. And you'll have to excuse me because I drew them out myself, so they're not all perfectly the same size. But imagine that they would be. Alright. So if you look at what we actually did here, we have one piece that's x squared, then the area of all the pink pieces is x, and so we end up with 6 of those. 6x was our middle term. The last term is 9, and well, if we have an empty box here that is 3 by 3, altogether that would be 9 squares, and each one of these areas is 1 without the x, so we get the constant 9. And our factor for this, as you know, is x plus 3 squared. Well, if you look at what's making up the lengths and the sides of this box, we have one side here that's length x and one side here that's length 3. So this whole thing would be x plus 3. And same for the opposite side, is also x plus 3. In fact, all the sides all the way around are x plus 3 because it's a perfect square. And you guys know whenever you find the area of a square, it's always length times width. So right here you can see that this is why we call it completing the square. And really all we're doing is finding the area of the square. That's what the function represents, x squared plus 6x plus 9. Alright. And so just to summarize, when you're finding a perfect square trinomial, let's say like the one we found before, x squared minus 10x, and we figured out that we had to add 25 to the end to make it a perfect square trinomial. Well, it's in the form ax squared plus bx plus c. In order to find the c value, there is a trick. So we want to take the middle term, which in our case was negative 10, and in order to figure out c, we're going to divide that number by 2, and then we're going to square it. So we end up with negative 5 squared, which is positive 25. That's going to work for you every single time. So to find c, you're taking b, dividing it by 2, and squaring it, and that will always give you your c value. So that would be a really good thing to write down on your paper there as you begin to work and try these problems. b divided by 2 squared. Alright, and then lastly, this one's a little bit trickier. X squared plus 3x plus c. We still have to find c, and we just said that our formula is to take b and divide it by 2 and square it. So looking at this function here, well, b is going to be 3. So it's 3 over 2 squared. At this point, you might think, uh-oh, well, 3 divided by 2, that doesn't actually divide evenly, but that's okay. That just means c is going to be a fraction. So you can still have a perfect square trinomial, even though your values are fractions. Your factors will just also have fractions. So right now, 3 divided by 2 doesn't do anything, but when we square it, we're squaring the numerator and the denominator. So you end up with 9/4 as c. So this function, or this equation, is x squared plus 3x plus 9/4. That is your perfect square trinomial. When you factor it, it's just as easy as before. You're starting with x. If your equation has two plus signs, then it's going to be a plus. If it were a minus here, then it would be a minus in your equation. And then thinking about, okay, what two numbers multiply to 9/4 and add to 3? Well, 9/4 is 2 1/4. 3/2 is 1 1/2. So when I'm thinking about what multiplies to 2 1/4 and adds to 3, well, the same number that adds to 3 is 1 1/2 and 1 1/2. And that's what, if you multiply, gives you 9/4. So in my fraction, or sorry, in my factor, we need the fraction 1.5 or 3/2 squared. So every time you're factoring one of these, it's going to be the b/2 that goes into your factor. Alright, so try assignment 13, see how it goes, and let me know if you need help.